So this video is about section 11.4, simplifying radicals. So you want your 11.4 simplifying radicals notes template out. So we're looking at how can I simplify perfect squares and cubes. So looking at this algebraically, if a squared equals b, then a is a square root of b. So we want to write in there, that would make a square root of b. If a to the third is b, then a is a cube root of b. So we need to remind ourselves of our perfect squares. So 1 squared is 1, so the square root of 1 is 1. 2 squared is 4, so the square root of 4 is 2. Now we have to remember that perfect squares also can be made from negative values. So we could say negative 2 squared is equal to 4. And so the square root of 4 can also be negative 2. So we can't forget that about the perfect squares. And so we know that 3 squared is 9. And that negative 3 squared is 9. Remembering that when we square a negative value, we put it in parentheses. And so the square root of 9 could be 3, or the square root of 9 could be negative 3. We know that 4 squared is equal to 16, and negative 4 squared is also 16. And so that makes the square root of 16 equal to 4, or the square root of 16 could be equal to negative 4. And we know that 5 squared is 25, and we know that negative 5 squared is also 25. So the square root of 25 is equal to 5, or the square root of 25 is equal to negative 5. So just kind of keeping that in mind. Unless you're kind of been told to just use the positives, you have to keep the negative values in mind. So I'd like you to try to complete the chart. So now you're trying to do the values from 6 to 12. And to do this the best way possible, I'd love for you to pause the video and fill out 6 through 12, and then check in when you're finished with that. Alright, so hopefully you paused the video and filled those out. You can check your values with what you have here. I'll give a little wait time for you to check your values, change any mistakes that you need to. So the next power that we're looking at is perfect cube. So we've got 1 to the third power, or 1 cubed, is equal to 1. And that is because 1 times 1 times 1 is 1. So that cube was referring to those three, the use of that base 3 times. And so the cube root of 1 is 1. And 2 to the third is 8, because 2 times 2 times 2 is equal to 8. So the cube root of 8 is 2. Notice that the negatives don't apply here, because if I made these values negative, it would change the sign of the answer. So we want to make sure we take those out, or we don't include the negatives. And so for the next one, we've got 3 cubed, and you want to think about what 3 times 3 times 3 is, which is 27. And so the cube root, where we show, like, it's the same thing as this radicand there, we just put a little 3 in there to show it's the cube root. So we say the cube root of 27 is equal to 3. And 4 to the third stands for 4 times 4 times 4, and that is 64. So that makes the cube root of 64 equal to 4. 5 to the third. It stands for 5 times 5 times 5, which is 125. And so that makes the cube root of 125 equal to 5. Now again, I'd love for you to pause the video, try to fill in 6 through 10. You can use a calculator, and then check in with the video when you're finished. Right, so those are the values you should have for the perfect cubes and the cube roots. Just giving yourself a chance to check those. And then we'll move on. So what we want to look at next is whether or not we can simplify the cube root of negative 125. So we're thinking about the cube root, we're trying to figure out what value as a factor 3 times will give us a product of negative 125. So if you look through your perfect cubes, you should get kind of a clue to that. You know, what cube root is related to 125? We've got negative 125. Well, that would be 5, but we want the product to be negative. So we can simplify that. The cube root of negative 125 would be negative 5 as a factor 3 times. So the cube root of negative 125, I guess, hold on, I'm not going to show those equal to. The cube root of negative 125 is negative 5. Let me erase the way I'm showing that there. And the reason that is the cube root is because negative 5 as a factor 3 times gives you negative 125. So to simplify a radical, we want to think about the perfect squares that are inside the radical that's there. So if you look at the square root of 12, 12 does not have a perfect square root. 12 is not a perfect square. But we can think about the things that make up 12. If we think about the things that make up 12, we of course want to target perfect squares. And 12 can break into the factors of 4 times 3. And 4 is a perfect square. So we can take out the square root of 4, which is 2, and then we're just left with the square root of 3 inside. So that radical is simplified. So you want to pull out any of the factors that are perfect squares and take the square root of them. So the square root of 12 is the same as 2 root 3, or 2 times the square root of 3. So we kind of took that 4 out, took the square root by taking it outside, and made it 2. We'll look at the next one. 75. Again, 75 is not a perfect square, but we want to think about the perfect squares that would be inside 75. 75 is the same thing as 25 times 3, and 25 is a perfect square. So in a way, we want to kind of take out the 25 by taking the square root of it, and taking it outside of the square root. So that would be 5, and then the root 3 is left inside. So we can simplify the radical square root of 75 by making it 5 root 3. Okay, so we have the square root of 225. Now the square root of 225 is in fact a perfect square. The square root of 225 is 15. But if you weren't sure about that, you could break it down into its factors. So you could think about, okay, so 225 is 25 times 9. And the square root of 25 is 5. And the square root of 9 is 3, and that is 15. So we can kind of simplify radicals to help us do things with mental math as well. When we have radicals or fractions inside radicals, we can simplify them by kind of looking at the numerator and denominator separately. So what we're thinking of here is, let's break down the numerator, 25, is a perfect square. 25 is the same thing as 5 times 5. 36 is the same thing as 6 times 6. So we can take the square root of the numerator and denominator, and then we say, okay, so the square root of 25 is 5. The square root of 36 is 6. So the square root of 36 is equal to 5, 6. And we just leave the numerator in the numerator and the denominator in the denominator. So we can do the same thing with letter B here. The square root of 100 is 10, and the square root of 144 is 12. Now we do have a little bit of an extra step here because we should reduce. So we think through, what can we divide both 10 and 12 by? Well, we can divide both 10 and 12 by 2. So we divide the numerator and denominator by the same value. 10 divided by 2 is 5, and 12 divided by 2 is 6. And so now we've got our simplified fraction. Now we can simplify the radicals here, even with cube root. We want to think about, okay, well, what is the cube root of 64? If you're not sure what the cube root of 64 is, check your chart. The cube root of 64 is 4. The cube root of 216 is 6. So we take the values out of the radicand by taking the cube root. Now 4, 6 can be reduced. We can divide both the numerator and denominator by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And so that reduces to 2/3. So in the next part, we're trying to solve for x, which means we're trying to find what value x could be. So if x squared is 225, what value or values could x be? So hopefully you said 15. And so x could be equal to plus or minus 15. So that's how we indicate, right here sometimes, that's how we indicate that your answer could be positive or negative. Next part, we're looking at x to the third being 27. So to find x, you're thinking about what value would x be in order to get 27. Now this one I'm going to show you a little equation solving format. We can undo cubing by taking the cube root. So I'm just going to show taking the cube root on both sides. That gives me x. You would find the cube root of 27, which is 3. So x is equal to 3. Now we can show the same kind of work for the previous one. We would just show the square root value on both sides. And here, in order to find out what x is in letter C, we would take the square root of both sides of the equation. And so if x squared is 16/49, then x is equal to, and we take the square root of 16 over the square root of 49. Now again, that is a squared value. So we could, if we're trying to be very careful, we want to make sure that we know our answer could be plus or minus 4/7. For the next value, we have a decimal. X squared is equal to 2.25. Again, we could take the square root of both sides. You want to think about 2.25 in the fact that it looks very similar to 225. So I'm going to think about that. Again, this is not necessarily work that you would show, but there's my thought bubble. I'm going to be thinking about 225. And the square root of 225 is 15. So I'm going to be thinking about that. And so when I think about that, then okay, so x is going to be equal to 1.5. So we're just like scooching the decimal over there. And again, that's square root, so it could be plus or minus 1.5. Remember to jot your questions down, highlight things you need to, and bring your questions to your teacher.